Hello and welcome to our ARM-based Embedded Systems Design Conference 2013. My guest now is Dave Hughes, CEO at HCC Embedded. Welcome.
Thank you.
So basically, processors are less important for you as a company like HCC than to the others that are here on the conference. So what brought you here?
We're here. I mean, ARM is an extremely major player in the embedded processor market. From a point of view of the software we produce deeply embedded software, file systems, networking stacks, USB software, etc. But the vast majority of that software is really not target dependent, or it should not be target dependent if it's coded properly. And if it's coded well and structured within a organized framework, you can make a large body of that software very independent of target. So you only have to worry about the peripherals. Peripherals are very complex, moving from even within the ARM range. The peripherals are very, very different. The point is that if you build a framework and your software isolates those parts that are target specific, you can invest very heavily in the quality of the remaining components.
I see. You mentioned several times now the framework. So can you give us more information about the framework that HCC does provide?
Yeah, I mean, I've just actually given a presentation, basically, which is almost a short history of HCC and how we went from developing on this microcontroller, that microcontroller with 10, 20 different tool chains, 10, 20 different RTOSes. And we had to develop some kind of system whereby we could reuse as much software as possible for the purpose of investing heavily in those pieces of software, getting the highest quality, and being able to provide a variety of different projects without having to re-engineer everything. And the net result of that is that we've built this framework, and it takes in a large body of issues, anything from endianness, APIs, configuration, cache management. But our embedded developers know how to develop within this framework. And now we have a thing on our website, for example, where you can go and build your own project, select one of 1,500 microcontrollers, one of 10 RTOSes, one of 10 tool chains, select components like class drivers, USB drivers, put it together, and we'll give you a quote for how long it takes us to build a project, and you'll get a working project to your desktop. And that is the advantage of the framework, in that we've built a system where we can scale the building of projects.
Okay, and where are the limits of that framework? What do you support?
Well, the idea of the framework is to be completely independent of any particular architecture or RTOS. Always there is a big dependency in the microcontroller on the peripherals, and that's the key point that changes. But that's even within the ARM. So you hear ARM. ARM is very standard, where you're talking about the core. But all the peripherals are very different, and even within microcontroller families, peripherals change, and that's where the struggle is. But we abstract those areas where we can see they're going to change in time over different environments, and because we've abstracted them, the core components don't change.
Okay, so thank you very much.
You're very welcome.